Hello, ladies and gentlemen, and welcome to our virtual testing forum webinar, How to Achieve Reliable Test Results on Thin Metallic Foils. To increase the performance of lithium-ion battery cells, ultimately the weight of its components must be reduced. Using thinner electrodes is a way to achieve this objective. However, determining the mechanical properties of thin copper and aluminum foils can be a challenge. So we are showing you today solutions that help you to reliably test thin metallic foils. Before we begin, I will show you the relevant GoToWebinar functions, followed by a brief introduction of Zwickrol, and then we'll go on to the presentation of the topic today, and followed by a short video. And then in the end, we will answer your questions that you have. Any questions that we are not able to cover will be answered then later in email. The session will today be about 35-40 minutes, and here you see the GoToWebinar software tool. So you will find the control panel on the right side of your screen. With this red arrow icon, you can minimize and maximize this panel. Please note that we muted the attendees' microphones, so you will not be able to talk to us. And we also will not use the function of raising hands during this session. However, you can submit any questions that you might have during the presentation using the questions panel on the right bottom side. So, Zwickrol is your experienced partner in materials and component testing. For over 160 years, we have helped companies achieve reliable test results. We are committed to long-term investments in innovative testing systems and testing software, as well as in the training of our employees. We want to understand your requirements and needs, and we offer consulting and can provide custom-fit testing solutions for any application. Our global service organization is on hand to support you whenever you need us, and our application laboratory in Germany is available to carry out a large variety of mechanical testing. All this allows us to support you in the ongoing development of your products and processes. So with me today is my colleague Stephanie. Stephanie, would you like to introduce yourself?
Yes, hello together. My name is Stephanie Rösner and I'm working since near than 15 years for Zwickrol in our application lab. And my job is to find the perfect or the convenient testing solution for your application.
Okay, thank you. Yeah, and my name is Alexander Koprivets, and I'm the industry manager for Zwickrol for the Zwickrol automotive activities. And yeah, I'm dealing with, let's say, new requirements coming from the industry, and here as well, let's say, any challenges that our customers are facing to provide proper solutions. So to now get your full attention, we will now switch off our videos and start then with the presentation. Okay, we talked about reliable test results. So let me first explain what we mean by reliable test results. We at Zwickrol and our customers consider a test result reliable when it is accurate, repeatable, reproducible, and traceable. And reliable test results are a fundamental and highly critical aspect of materials testing. I'd like to define first accurate. According to the definition, accurate refers to a true and precise measurement. This shows that the expressions must be examined again more closely with regard to the significance for the testing technology. So why is that important? It's important so that we all really understand the same thing by them. Trueness is a measurement of the agreement between the average value obtained from multiple test results and the true value or reference value. However, this tells us nothing about the degree of scatter for the individual values, or in other words, how precise these are. Precision is a measure of the closeness of the agreement between independent test results obtained under stipulated conditions. However, this still does not mean that the values obtained by measurement are also true. They can be precisely untrue due to some systematic errors. Looking at repeatable, repeatable is the precision under repeat conditions. So we use for the test the same measuring method, the same operator, the same measuring equipment, the same location, the same test conditions, and all those tests are performed within a short period of time. So the only variable factor in this testing process is the time interval between the tests. Looking at reproducible, this refers to a statistical measure for measurements over a lengthy period, usually with multiple operators and testing equipment. This would be typically 2 separate testing labs in different countries, for example. So in other words, reproducible means that we have precision under reproducibility conditions. This is different from repeatable, for which all factors except the time interval can vary. For reproducible, only the measurement procedure must be the same. Everything else, like the equipment, the operator, the timing, the test conditions, can be different. This means that all other factors such as, as I mentioned, measuring equipment and so on, must be comparable, but they can vary. Okay, and last, the definition of traceable. This refers to the full and complete documentation of the development of a product or a measurement. For metrology, particularly, this means the traceability is the continuous documentation of the calibrations of all measurement chains and thereby the establishment of a reference to a national or international measurement standard. So we need to make sure that the test results are accurate, repeatable, reproducible, and traceable. Okay, let us look at the test process to understand what influences the test results. So I will show you a simplified test process, which is similar for all kinds of mechanical tests, be it a tensile test of a coupon or a functional test on a component. So it's important that this the whole test process is properly managed, and I'll show you what we mean by that. So the first thing is specimen preparation. A good specimen preparation is key to achieve reproducible test results. The influence of a poorly prepared specimen can be very high, and even the best testing equipment cannot compensate for that. Then it's the dimension measurement. For dimension-related measurements, like stress or modulus, it is important to measure accurately the specimen's dimensions. Here, even small errors can lead to a big influence in calculated test results. Specimen handling and conditioning plays also a big role for accurate test results. If not handled with care, a specimen can get damaged or influenced in a negative way, which in return can lead to wrong test results. The most critical part is the test sequence itself. And all the elements of a testing machine play an important role in achieving reliable test results. Here, the performance of the load frame, suitable grips or fixtures, the accuracy of the load and strain sensors are key to extract the best possible data from the specimen. And once the measurements are recorded, it is the role of a good testing software to determine reliable test results and provide the test report. We must not forget that in all these process steps, the operator plays a crucial role and does actively influence the quality of the test result. So that's very important to keep in mind. Okay, so what are the challenges? Why do we need to perform good tests on thin foils, electrode foils, which are being used in the production of lithium-ion batteries? Here, typically, we talk about the anodes and the cathodes, which are either copper or aluminum based. And the foils are put under a lot of stress and loading during their production process and also in operation. So it is important that these foils that are being used are properly characterized and that their properties are well known, so that later on in the production process or in operation, nothing unexpected can happen and the foil performs to its design. So what are some influences that we see? For example, coil storage is critical. If coils are not stored properly, specifically copper foils, there can be negative influences like corrosion. In the production process, you have a very high roll speed in the production process, which can lead to local stresses stresses if the alignment of the rolls is not perfect, and so on. So these electrode foils can suffer. In the calendering process, for example, we have very high compressive forces, which if the material is not properly of good quality, you may have problems due to local stresses. The slitting cutting process for stacking, for example, is important so that the edges are not damaged in a sense and proper for the use in the battery. Also in the drying process of the coating, you have high temperatures that are influencing the foil. So also here the foil needs to be tested according to these high temperatures. And then later on, of course, the foil needs to be free from dents and scratches generally, so that there is nothing that could lead to some kind of problem later on. In the operation, you have lots of thermal stresses, also mechanical stresses on the foil, which are sometimes so high that the foils can fail under these stresses. So the good quality foil needs to be ensured. And we have shocks, we have impacts, we have weld processes which provide local hotspots, and so on. So there's a lot of stresses that the foil needs to take, and therefore the testing is important before the foil is being put into production and operation. Okay, so some general requirements. It is important that whenever you do testing on foils, you need to follow the appropriate standards that you and your supplier or you and your customer have agreed on. And it's important to understand these given test standards. So they typically give clear indications of how to be tested, how the test has to be performed. It is important to really understand and to follow those informations in the test standards. Use this information also to define a test procedure for yourself. So if a test procedure is established, you can be sure that every time you do the test and you follow the test procedure, you can ensure that you have repeatable test results. And that is a key to be sure that the tests are okay. Another important thing is use up-to-date and well-maintained equipment. This is important for specimen preparation, specimen conditioning, but also for testing. And that is actually the basis for reliable test results. And I mentioned before, operators have a very high influence on the test results. And if they're well trained and if they're capable of performing the test, that is already half of the battle. Okay, looking at sample preparation. Sample preparation is critical. Generally, handle with care. Handle the specimen with care at any given time, mainly to avoid any kind of mechanical damage. Because damaged samples, they break prematurely and they give you lower tensile strength and strain and break, which then doesn't give you the real mechanical properties of the sample. Choose the right sample. It can be either dog bone sample or a strip sample. Typically, most of the times it's a strip sample, but use every time then the same sample size, because you cannot really compare 100% the results from one to the other. Choose a sample cutting direction from the sheet. You can cut in the longitudinal or the transverse direction from the sheet. Again, here you may have differences in the mechanical properties, so make sure that you compare really the same samples coming from the same direction of the sheet. Choose a good specimen cutter. There are different ways of cutting. You can slit, you can mill, you can use a foil cutter, you can have a stamping process, or even laser cutting is being employed. Just make sure that the cutting process is good and provides a good specimen quality, especially that the edges of the specimen are smooth. When you store the sample between processes, make sure that the storage conditions are okay, and that there's no unwanted condition coming into that, like too hot temperature, or you have unwanted humidity, or even just putting the sample to sunlight can sometimes influence its mechanical properties. Again, important for repeatable results. Visual inspection is also important. So before testing, make sure that the sample has no creases, not just dents or scratches, because they are actually breaking points or regions of failure. So a perfect sample should be used for perfect testing. And of course, again, for sample preparation, the standards give good indications on how to prepare the samples. And here, follow those guidelines whenever possible. Okay, choose right, and then for that dimension measurement, choose the right thickness gauge. In order to determine the thickness of a sample, make sure that you have an appropriate measurement device that allows you to measure the thickness accurately enough and repeatedly enough. Here you need to make sure that you apply the right force, that this force is constant when measuring the sample. And yeah, if the thickness of the specimen is lower than 50 microns, then typically weighing is being used to determine the specimen thickness. Here, again, you need to have then the proper weighing system that allows you to measure very accurately the weight of this very thin foil. One thing just to remember, measure, do not assume. For thickness measurement, for example, it is very important to measure. The thin foils are always very thin, but it's very easy also to just assume, okay, yeah, this is a 20 micron foil, but in the end it's a 30 micron foil. So make sure that you measure and that you don't assume the thickness or what is written on some kind of identification paper. So just be sure to avoid common mistakes. Specimen handling, again here, I repeat, handle specimens with care, because only then the best possible material properties can be measured. Avoid touching the specimen with bare hands, especially in the reduced section of the specimen. Outside of that reduced section where the measurement actually is happening, it's okay, but inside it's critical. Reduce sweat, avoid sweat, moisture, temperature, dirt, which can influence the surface of the sample. Reduce mechanical influence. So if a sample falls down or bends, you actually already damage or pre-damage the sample. Avoid that. Make sure that if you have some kind of mechanical damage already in there, take a new sample and test sample properly in good conditions. If possible, try to minimize the operator influence, because here a lot of experience, a lot of feeling is required to be able to test the samples properly. So make sure that the operator is well trained. If you cannot guarantee that, there are some tools to help you to help him to feed in the samples. We provide also automated feeding systems for our robot test systems. So there are tools of improving that. Then, of course, testing is very important, and the testing machine here is important. Set the right test speeds, again, following the standards, and make sure that this machine that you're using can perform the speeds. This is repeatable, important for repeatable measurements, specifically for important values like yield strength. Ensure that the measurement of very low forces happens within the calibrated load range of the load cell. So every load cell has a calibrated range, and if you measure, or if your maximum force or the force that you want to measure falls is measured outside of the calibrated range, your measurement actually is invalid or not confirmed. Therefore, make sure that you always measure in the calibrated range of the load cell. And of course, all those sensors have to be calibrated regularly on a regular basis. But that is not enough. Make sure that you regularly check your system, your load cell, for example, that it measures properly. This can be done with just putting every day a small weight on the load cell to measure to compare its measurement with the weight of the device. And if that's okay, then you can use it, or use some reference spring with a known stiffness, which also gives you a good indication if the load cell is still okay. For strain, yeah, okay. And last, you can have some technical devices, some calibration load cells, which you can use for those daily checks, but that is a more expensive solution, but of course the best solution. For strain-related measurements, use a non-contacting extensometer, either video-based or laser-based, because here you only then you can ensure that the extensometer is not touching the sample and damaging the sample. So strain-related measurements always with non-contacting extensometers. Make sure that when you preload the sample at the beginning of the test, that you don't overshoot the preloading and to avoid damaging of the sample. So the machine must be good enough to really reach a good preload and then start a test. And for temperature-related tests, make sure that you have a good temperature chamber with a good temperature distribution, and also with a very controlled airflow within the temperature chamber, so that the very thin foils are not influenced by too harsh airflow. Okay, for the gripping, also very critical. It's important to grip the sample properly. Use pneumatic grips instead of screw or wedge action grips. This is our recommendation, because pneumatic grips allow you to have a constant and repeatable gripping pressure that allows that the specimen will not slip, but also will not take any damage, which allows you then to get the true or maximum forces and strains measured. Take care of the grip alignment and the specimen alignment. So make sure that the specimens, when you insert them, are perfectly aligned, because that avoids any damaging stresses and moments during the tensile test. And choose the right jaw inserts. We recommend for these tests typically rubber and the aluminum convex configuration that you see on the left side of the pictures, but also rubber against rubber is okay, and in some cases is flat steel jaw faces are also okay. The advantage with so that's this overview. And then for the data, here typically software can be a black box, so we all believe that what the software is calculating is right. Check, verify that those calculations are okay. There are some processes available that we also offer with our testing software, Test Expert 3, where you can read in some raw data, reference raw data. You can then let the software calculate that data and then compare the calculated results with some reference results that are given to you. This ensures the confidence in your reliable test results and make sure that your software is calculating properly. And also use predefined test programs. It's something that helps you just in your daily work, so it's easy to set them up. So make sure that the software provides you kind of pre-configured test programs. And important for the traceability of your tests, make sure that the software can register when the test has been performed, who did the tests, how did they test them, and what did they do during the test, as well as why they did some changes if necessary, and who was in the end responsible for the test. So this is something that is required for, let's let's say, traceability reasons, and it's important that the software can give you the full traceability, even for tests that have been performed years ago. Okay, so this is about the requirements for the test data. I would just highlight one other element here. We were talking about copper and aluminum foils. Now, if you're looking into more challenging foils, here an example, testing lithium metal foils, which are one element for solid state batteries, and understanding their mechanical properties, that is, of course, a different challenge, because this material, lithium metal, is very sensitive and quickly degrading in ambient atmosphere. So here you need to consider a specially designed inert gas chamber that allows the conditioning and the manipulation of these lithium metal specimens. Particularly challenging is the handling of the sample inside of the chamber. For that solution, we have designed a special tool that enables us to insert the sample very safely and without, again, damaging it before testing it. And yeah, this is, for example, a challenge. And if you have any kind of challenges, we are always very happy to listen to your challenges and try to provide some kind of solutions that help you in your testing requirements. Okay, so now I would switch over to our short video to show you, let's say, the process of testing a copper foil. And I'll just switch the video quickly.
So we make the sample preparation for the tensile test on electrodes. We have a copper foil. As we see that our copper foil in our example is not anymore the best. It's full of wrinkles and a little bit damaged. But it should be only an example for preparation now. So we clamp the foil and then we cut with one run a strip of, in that example, 50 millimeters. Important is that the edges are really clear and sharp. That means without some damaging and notches. Okay, so we are back on our testing machine with our prepared sample. What we see here is a universal material testing machine. It's an extra high version, and kind of we use a temperature chamber. In the real life, it's important for the material to use or to test the material in different temperatures. Normally from minus 20 degrees up to 50 degrees. Then we have pneumatic grips. Pneumatic grips are good in that case because we have quite thin foils and the clamping pressure will always constant and it's not depending on the user. We use an extensometer, an optical extensometer. In that case, a laser extensometer. It's important to use optical because if we use the touching extensometer, we will damage the sample because the foil is quite thin. Good, but before we begin with the test, we go to our measuring. We know already the measuring of the white because we know the knives. And what we have to measure is the thickness of the sample with a micrometer. That's important. We use a micrometer and not a caliper because of the accuracy. That micrometer is connected to TestExpert. That means we make the measuring and send the value to TestExpert and then we are ready. Okay, I fixed the sample. For fixing the sample, we use the feed control to close the pneumatic grips. Normally now I would close the safety door, but in that case we don't use the safety door. It's important if you have some brittle material. And also important is the adjustment of the sample. We can check the alignment also with our optical extensometer. So let's start the test. First we go up to a little preload, and then we will change the speed to the module speed and later to the test speed. We test according to ISO 6892 or ISTM E8, whatever. So now the sample is broken. We have a break in the free lengths, that means between the first and the last clamping point. Okay, and that's the test, tensile test on copper foil.